What's up, algebra geeks? It is time for factoring trinomials. Yay! So in our unit on polynomial equations, we're spending a lot of time on factoring because we need to use it to graph these things eventually. So far what we have covered with factoring is greatest common factor and factoring by grouping. And now we're getting into like the most popular piece of factoring ever, factoring trinomials. And the instructions that I'm giving for this set of examples is to factor each polynomial using any method. So in this video, I'm actually going to cover a handful of methods that you can choose from to factor trinomials. And the first thing we want to talk about is a trinomial model, and we basically stick with a quadratic trinomial model. So just make sure, and I'm gonna make references to this later on in this video. But when we talk about a trinomial model, it's normally quadratic, and so I'll spell quadratic correctly first. So a quadratic trinomial model follows this suit: some number times x squared plus some other number times x plus some constant number. Okay, and that is a trinomial model. So it's ax squared plus bx plus c. It's called standard form, and we'll use it a lot throughout the year. But for this unit, I want to use this trinomial model, a quadratic trinomial model: ax squared plus bx plus c, some number times an x squared plus another number times x plus a constant. And so we'll get back to that later, but when we talk about trinomials, we're going to use that model. So there's a few methods I'll cover in this video for these examples, but I first want to start with a different example so I can show you using Algebra Tiles. So another example that we can start with is if we were to factor the trinomial x squared plus 5x plus 6. And how would we factor that? First one, I'm going to show using Algebra Tiles. So remember what factoring is. Factoring means we're going to express it as a product. Okay, so we're going to express this as a product, and we'll find out the area model to use it. So we're going to express this as a product with Algebra Tiles. We have an x squared. We have 5 x's and 6 ones. Okay, so we're going to talk about this with Algebra Tiles. So how can we talk about factoring with Algebra Tiles if I'm talking about an area model? Well, in order for an area model to work, we need a rectangle, don't we? And it's hard to make a rectangle with these Algebra Tiles the way you see it, even though this most definitely is x squared plus 5 x's and 6 ones. This doesn't make a rectangle because you see like the ones kind of like jut out a little bit. This is not a rectangle. So can we build a rectangle with these tiles? And we can play around with different shapes and all that stuff. How do we make a rectangle with those tiles? And here's one way we can do it. If we were to make a rectangle, a perfect rectangle with these tiles, one might look like this. You'd have to play around with it, and you'll see, we're going to end up with a rectangle. And voila, check it out, a rectangle. So we have actually constructed a rectangle with these tiles. And this is a perfect rectangle, right? No doubt about it. It's all, all the two opposing sides are congruent and all that stuff. So we've made a rectangle with these tiles, and all we need to do now is figure out what were the dimensions. Okay, so remember the rectangle, the area of a rectangle is length times width. So this is still 5x, or x squared plus 5x plus this. That's what this is, right? So now what we can do is figure out the dimensions. So what were the dimensions of this rectangle? Well, we have length times width, or base times height, or what have you. The one distance, remember, length is from here to here is x, right? We don't know. So this is x, right? And this is 1, 2, 3. So that's x positive 3 that way, right? So we have the dimensions there. And then the dimensions down this way. Again, this is a distance x, and then this is distance positive 2. So we have x plus 3 along one way, x plus 2 along the other way. And when we multiply those two dimensions, we get x squared plus 5x plus 6. So what does that mean? That means if we were to express this as a product, what we're actually looking at is x plus 3 times x plus 2. So we can use the area model to demonstrate that's how factoring can work. Okay, so we had the trinomial x squared plus 5x plus 6. The dimensions to get there is x plus 3 times x plus 2. We've expressed that as a product. We have factored that successfully. So that's one way we can approach factoring. It gets problematic if you want to use algebra tiles. It gets problematic because this was easy to use. We had 1x squared, 5 x's, and 6 1s. That's easy. Well, what about this example when we talk about our whole thing? What about x squared plus 9x plus 20? Yeah, we could totally use algebra tiles. No worries about that. But we have to have now 9 x's and 21s. You're going to fumble around for years and years and years. So I'm going to show you another method. So another method I'm going to show you deals with factoring by grouping. So that's going to be another method we can use. We're going to factor by grouping. And the way we factor by grouping is that we take the quadratic model that I had talked about, ax squared plus bx plus c. We take the quadratic model and we work with it. Okay, so this method is going to be called factoring by grouping. Okay, and we'll see if you like this method. So how is it can we factor by grouping? Well, the first thing we're going to do is take that middle term, bx, and call it blankety blank. Okay, so we're going to have, instead of having a bx, we're going to have a blankety blank x. That's what we'll have in the middle. Okay, so we'll have our things going on there. Okay, so we have x squared blankety blank, right, and then plus 20. Okay, so that's how we can set up factoring by grouping. And so we're going to use blankety blank, and now the only deal is, well, we got to fill in the blanks. This is where things get a little bit tricky, but useful later on. So now, how are we going to fill in the blanks? The first we're going to do is multiply a times c. Okay, so we'd multiply a times c, and we get ac. We get some number. And so for this example, we have 1 times 20, or AC is actually 20. And now the key question. So we multiply A times C. The key question is, what multiplies to A times C but adds to get B? Okay, so what can we multiply to get that number 20, but adds to get us 9? Okay, so what multiplies to AC but adds to B? This is the key question. All right, so when we look at the example number 1, we have A times C is 20. So the question is, what multiplies to 20, but then we add to get 9? Okay, so what two numbers multiply to 20 but add to get 9? And hopefully by now you have figured it out. It's 5 times 4. Because what we can't do is, 1 and 20 doesn't work, and 2 and 10 doesn't work, and 3 doesn't go in. 4 times 5 works, right? Bingo, 4 times 5. Because they multiply to 20, 1 times 20, multiply to 20, 2 times 10, multiply to 20, 4 times 5. 4 times 5 adds to give us 9. So what do we do with that 4 times 5? We fill in the blanks. All right, so step 3 for factoring by grouping is fill in the blanks. All right, so if we're going to factor by grouping, we're going to fill in the blanks. So in this example, we're going to fill in the blanks with a 4 and a 5. Positive 4, positive 5. Okay, so we have filled in the blanks. So this is how we can factor trinomials by grouping, and this works all the time, if the trinomial can be factored anyway. So when we factor by grouping, so far we have set up the blankety blank. We multiplied A times C, and then we figured out what multiplies to A times C but adds to give us B, and then fill in the blanks. And then last step, factor by grouping. So that is the last step of factoring by grouping, is actually factoring by grouping. And please see the previous lesson on factoring by grouping. So in our example for number 1, we had our trinomial, and we set up our blankety blank, and we answered the question what multiplies to 20 but adds to give us 9, 4, and 5. Now what we can do is factor by grouping. So we take the first two terms, x squared plus 4x, and we take the second two terms, plus 5x plus 20, and we then factor by grouping. Okay, so this is where the previous lesson comes into play. And if you remember how we factor by grouping, I hope you do. The greatest common factor of the first group is x, and so we're left with x plus 4. And the greatest common factor in the second group is plus 5, and that will leave us also with an x plus 4. And voila, we can now see, hey, there is a greatest common factor there, the x plus 4s. And so when we factor by grouping, we can find out, hey, we can factor x plus 4, and then we're left with x plus 5. So that is one way we can factor trinomials. X plus 4 times x plus 5. Okay, so no matter which way you factor trinomials for that first expression in number 1, we're left with x plus 4, x plus 5. There is another way that we can factor trinomials. So I'm going to show you another way. I'm going to call it the, well, I don't know if I've named it, but I've heard it be called the X-factor model. And so we look at number 1. We have also the X-factor model. I like using the X-factor model for factoring because it's fun. So again, we have our quadratic model, ax squared plus bx plus c. Why do we call it an X-factor model? Because we're going to make a giant X. Meow, meow. Okay, so we're going to make a giant X, and so what we'll do in problem number 1 is make a giant X. Meow, meow. Now it's hard to use the model to go over how this works, but you'll see in a second through here. So the first thing we're going to do is figure out what two numbers multiply to give us x squared. And you want to figure out, well, the two numbers that multiply to give us x squared are x times x. Okay, so we look at this little section here. We come up with x times x. Okay, so those are the two numbers that multiply to give us x squared. And then we look at our 20, and then we figure what two numbers multiply to give us 20. Okay, what two numbers multiply to give us 20? And you can come up with your 1 and 20s, right? You could do 1 and 20 and 2 and 10 and 4 and 5. And the easiest pair to start with is the pair that is closest together. Okay, the pair that's closest together is 4, 5. So that's a little note. You want to start with the pair that's closest together. And you also want to do another thing, is avoid common factors in that pair. Okay, avoid common factors in the pair. So when you're working with the X-factor model, you want to start with the pair that's closest, and you want to avoid common factors in the pair. Okay, so 2 and 10 has a common factor of 2. So avoid that, but it might work. You never know. Anyway, we can clearly see that 4 and 5 are the two numbers we're going to work with. So just like we put x and x here, we're going to put 4 and 5 here. And now what we're going to do is run the test. We're going to multiply across the x. Okay, we're going to multiply across the x. And so we have 5x across one way and 4x across the other way. And notice I haven't dealt with signs at all. We know since this is a positive 20, these are either both positive or both negative. Okay? So the positive 20 is either both positive or both negative. Okay? So the question then becomes is, can we use those two numbers, 4x and 5x, to add to give us a plus 9x? Right? And that's the question we ask. And clearly, yeah, that totally works. 5x and 4x gives us 9x. And we know both of those would have to be positive to make that work. So this is a plus 5x and a plus 4x. And that would add to give us 9x, which is what we want. And so now what we can do then is say, well, this was a plus 5, this was a plus 4, so this was a plus 5 here and a plus 4 there. Guess what our two factors are? X plus 4, x plus 4, and then x plus 5, x plus 5. So we have factored the trinomial that way, called using the x factor model. Okay. There's one more way I'll show you, and then we'll knock out these polynomials. Okay. So one more way to show you. We'll start with number 1, and it's a mental math way. Now the mental math way works only if a is 1. Okay. Well, it can work all the time. So there's a mental math way. It works best if a is equal to 1 in the model ax squared plus bx plus c. Okay, so if a is equal to 1, what do? Well, we simply set up ax times x, and then we set up our things and just start using mental math. Right? What can we do to multiply to get ac but as if it's b? It's a mental math way. It comes with practice. It's a think aloud. So if I use a mental math method for number 1, I would set this up first. Okay, so the think aloud then becomes what multiplies to 20 but adds to 9. Okay, so that's the mental math piece. What multiplies to 20 but adds to 9? And again, the answer's 5 and 4. Both are going to be positive because it's a positive 9 and a positive 20. So plus 5 plus 4. Mental math. Okay? So there are these methods that we can use. You can factor by grouping. You can use the x factor. You can use mental math to guess and check. And of course, this all can be modeled using algebra tiles, but it gets cumbersome. Okay, so those are the methods that I'll show today, because these are the ones that I like using the most. And with practice, you can become awesome at factoring trinomials, because that's like the key skill for graphing crazy stuff. So now we know our factored expression, number 1, x plus 4 times x plus 5. So what about in the second expression, number 2? X squared plus 3x minus 54. So with number 2, x squared plus 3x minus 54. The method I'll show for this video, and it doesn't matter which method you use, but the method I'll show for this video, because I don't use it too often in teaching, is the mental math method. So I'm going to use mental math for this one. And the way I'm going to do it is set up my product already, because I know my first terms are going to multiply to x squared. I already know that, so I'm going to use a mental math product, or the process. So now the mental math question is, what multiplies to negative 54, right? What multiplies to negative 54 but adds to positive 3? Okay, so what multiplies to negative 54 but adds to positive 3? Then you go through your times tables, and hopefully you come up. I know that I'm going to deal with a 6 and a 9, right? But if I'm adding to positive 3, that means the 9 is going to have to be positive and the 6 is going to have to be negative. Done. The 9 is going to be positive. The 6 is going to be negative. Mental math. Okay? But if you use the process for factor by grouping, if you use the process for x factor, it still works the same. But we know we can factor that second example using mental math, or we can use any other method. So there's number 2. Right? So we have factored that trinomial. But now we move on to number 3. Number 3 is interesting. So we look at number 3, and we say, okay, well, we have 5x squared minus 45x plus 70. Notice anything cool? I hope you do. Hopefully you notice there is a greatest common factor. So hopefully you notice there is a greatest common factor. I'm going to yell at you. Okay, GCF, exclamation points. So if you notice anything cool about that, greatest common factor, that means we can factor out the greatest common factor. And so that is what we're going to do. We're going to factor out a 5 from the entire expression. And when we factor out a 5 from the entire expression, we're left with, I think that's it. Wait, 5 goes into 70, 1 remainder of 2. Nope, 14. So I made a boo-boo there. That's 14. That's a boo-boo. So we factor out the expression, and we get x squared minus 9x plus 14. Okay? And now what? Well, now we have to factor this trinomial. Okay, so can we factor this? And the answer is, well, maybe. All right, so now this is what we're going to have to factor. And we can use any method we want. So for this example, I'll use blankety blank. Why not? So I'm going to use factor by grouping for this method. Okay, so notice we have the 5 is way out here. And now I'm going to use factoring by grouping. X squared, blankety blank, and then plus 14. And if you remember how this method works, what we have to do is multiply a times c. And since we're only factoring this trinomial, we're only going to multiply a, which is 1 in this case. I'm only paying attention to this trinomial times 14. So I'm looking at the number 14. All right, so what two numbers multiply to 14, but then add to negative 9? All right, so that's the question. If you won't remember, that's the key question. What numbers multiply to 14, but add to negative 9? And that's the key question through this whole thing, by the way. And you go through your times tables for 14s, right? 1 and 14, 2 and 7. 2 and 7, 2 and 7, bingo, bingo, 2 and 7. But they're going to add to negative 9. So we know we're going to deal with negative 2 and negative 7, because a negative times a negative is a positive. Yay! And so we fill in our blanks with minus 2, minus 7, and now we're ready for factoring by grouping. So we're going to group the first two, x squared minus 2x, and then the second two, minus 7x plus 14. Remember in the lesson on factoring by grouping, I talked about how important that sign is, right? So we're going to see why. Greatest common factor here is x, so I factored out, I'm left with x minus 2. The greatest common factor here is 7, but I'm going to factor out that negative 7, that minus 7. And what's going to be left inside is going to have to match that, right? So it turns out that totally works. X and 14 divided by negative 7, negative 2. So that's why the signs are really important, by the way. And now I have a common binomial in x minus 2. And then what's going to be left? X minus 7. Okay, so factoring by grouping turns out to be super huge. But if you remember, this is part of a whole bigger thing. We had that 5 that was out there, right? So we still have to keep into account the 5 that was out there. So our entire factored expression is 5 times x minus 2 times x minus 7. That is our entire factored expression from the original trinomial. So to factor this, we have broken it down into its components factors. We have expressed this as a product. Okay, it just happens to be a product of 3 things. And that is number 3. So we could use it that way. Now on to number 4. So we look at number 4, and it looks like, well, I don't know what we can do with number 4. So let me just jump right into one of the methods of factoring. But it's up to you. If you can't see, well, pardon the bell. If you can't see that there's a GCF in number 4, then go, start factoring it. But guess what? There is a GCF in 4. The GCF is the number 3. Okay? So the greatest common factor here is 3. So when we factor out of 3, we're left with x squared minus 2x minus 27. Okay? So we have x squared minus 2x minus 27. What I'm going to use now, mental math. So I'll show you mental math again. So I have x here and an x here. Right? In my mental math, what multiplies to negative 27 but adds to negative 2? Right? What multiplies to negative 27 adds negative 2. Hopefully the numbers 7 and 9 start jumping out. But one of these is going to be negative, one's going to be positive. If they're adding to negative 2, the 9 is going to have to be negative. So now I see the 9 is going to have to be negative. Minus 9, positive 7, and now I'm done. And you can always multiply back to check, by the way. You can multiply back to check. But that's we'll save that for another lesson. And so we have our expression here. Okay? A few more to cover, and then we are good to go. So now we look at number 5. Now we're out of luck. No more greatest common factor, right? So number 5, we have 3x squared plus 8x plus 4. We can use the x factor here, or we can whatever method. I'm going to use the x factor. So I'm going to show this in practice. How does the x factor method work? Well, if you remember, we draw that big old x, right? And then we figure, so what are the two numbers that multiply to 3x squared? Well, one of them is going to have to be 3x, and the other one is just going to have to be x. This is how that works. Those two multiply to 3x squared. And then what are the two numbers that multiply to 4? Okay, so what numbers multiply to 4? Either 4 and 1 and 2 and 2. Okay, 4 and 1 and 2 and 2. And so I'm going to try out 4 and 1. And then I'm going to multiply across to get 3x here, and multiply across to get 4x here. Can I add those in any way to get a plus 8x? I can't. No. So 4 and 1 doesn't work. But what about 1 and 4? Okay, and I multiply across again. So I'd have 12x here and 1x there. Can I add those up to get 8x? No. So that's not working. Therefore, it must be 2 and 2. Right? And is that going to work? 3x times 2 is 6x here and 2x there. Is that going to work to add up to 8x? Yes. Yes, it will. And they're both going to be positive, right? So it's both going to be plus. So I'd have a plus 2 here and a plus 2 there. I'm left with 3x plus 2. I like this method, by the way. 3x plus 2, and then x plus 2. I have now factored my expression. Okay, so we can use the x factor method there, and it works that way. All right, 2 more. So the next one, we can use factor by grouping, and maybe that'll work. Okay, so the next one, factor by grouping, so I can model that as well. So we have our expression, we have 2 variables, big deal. So I'm going to use factor by grouping, blankety blank, right? X squared blank, xy this time blank, xy, and then plus 4y squared. As you can see, my class is waiting for me to finish the video. Now I'm going to multiply a times c. And if you remember, a times c is not always c, because in this case I'm multiplying 6 times 4 is 24. Right? So what are the two numbers that multiply to 24 but then add to give me 11? So what are the two numbers that multiply to 24 but add to give me 11? You come up with 8 and 3. So we'd have plus 8 plus 3, and now we are set to factor by grouping. All right, so our first group, 6x squared plus 8xy, and our second group, plus 3xy plus 4y squared, and we look for the greatest common factor. So the greatest common factor in our first set of numbers is going to be 2x, and if I factor that out, I'm left with 3 plus 4y. And in my second group of numbers, my greatest common factor is a plus y, and I'll be left with 3x plus 4y, and now I see my common binomial. Okay, so all of this plays out very, very well. And now I have factored my expression. All right? And now for the last one. And then I can let my class in and they can enjoy a quiz. They don't know there's a quiz coming, but they will once they watch this. All right, so the last one. We have negative 20 x to the 5th plus 54 x to the 4th minus 10x cubed. As you can see, there's going to be a greatest common factor. So you can see there's going to be a greatest common factor, but what we're going to do I'll let my class wait. But what we're going to do is to make sure that A is positive. Make sure A is positive. That's a huge note. And if we're going to make sure that A is positive, we're going to factor out a negative GCF. So that means we're going to factor out a negative 2x to the third power. Okay, so that's going to be a huge note. We want to make sure that A is positive, so we'll factor out a negative number. That's going to leave a positive 10x squared, a negative, 27x, and then a positive 5. So that's what's going to leave us making sure that A is positive. So we're going to factor this trinomial any method. I'm going to use the x factor method. So what two numbers can multiply to 10x squared? I'm going to try out 5x and 5x to see if that works. And then the two numbers that multiply to 5, I'm going to try a 5 and a 1. And I'm going to multiply across 5x here, 25x here. Can I add those to get to a negative 27x? And the answer is yes, I can, as long as both of them are negative. So if both of these are negative, we're good to go. So it'll be a minus 5x, that makes this a minus 5, and a minus 25x makes this a minus, and so we are good to go. So now our two factors are 5x minus 5, and then 5x minus 1, and then I realize, hey now, I just missed out on a greatest common factor somewhere because, boy, I actually messed this whole thing up, didn't I? Didn't I? 5 times 5 is 25. So if you made it this far, congratulations. I just ruined this whole thing. I should probably edit the video out. So I know that that's not going to work because my x factor then, if I'm to factor out 10x squared minus 27x plus 5, I need to deal with a 5 and a 2. Isn't that helpful? So now I have a 5 here and a 1 here, and that's what's going to work. Okay, so look how fast I fixed that. 5x minus 1, 2x minus 5. That's much better. So my entire factored expression, thank you for your patience, is going to be here. What a huge flub. But anyway, now I can let my students in. And they're going to take a quiz in a little bit. So anyway, there's that expression. Sorry for the mess at the end, but hopefully you learned some things. I'm out of here.